So now in recent videos I've been using light dependent resistor, so we're going to bring it back to this video because it's a cool component. It makes a sensor, a light sensor. So we have a 74HC14 integrated circuit here. It has 6 NOT gates. They're logic gates. You give a high input, you'll get a low output. It connects to ground. The blue LED will light up, as you can see there. If you get it dark enough, then you'll get a low input there. You'll get a high output, and the red LED will light up. So you can see the blue LED is lit up. We know that the output is low. I make it pretty dark there, and you can see that the red LED lights up. The output went high. So later on we're going to look at the voltages. Now we can adjust the sensitivity. Instead of a 10 kilo ohm resistor, I'm going to grab a 1.5 kilo ohm resistor, and this isn't my favorite value resistor for this, but it works. There's not a lot of resistors in around that range with the kit that I got, so I can't fine tune it as much as I want. So we got to get it really bright now to get a high input and set the output low. And now you can see the Schmitt trigger hysteresis. With the light level we got, the output stayed low. I have to dim the lamp a bit before the output goes high right there. So we had that middle ground region where it could be either high or low. So now of course it's best to look at the voltages with an oscilloscope. So yellow is the light dependent resistor. I have a little metal jumper in the board to make a connection, and looks like I gave a false trigger. That was enough to set the output low. But we're in the hysteresis range where it could be one or the other right there. And so I turned the lamp off. That dropped the voltage of our signal enough at the input for the output to go high. And since we got the hysteresis, the middle range, it's going to stay there. You can see I can dim the lamp. It goes down a little bit, make it a little brighter. I have to make it really bright to finally get it to change. But we got that hysteresis, so it's going to stay in place there until we get it dark enough, as we saw before. So now I'm going to yank the 1.5 ohm resistor. We're going to go back to the 10 kilo ohm resistor. This is how we adjust the sensitivity right there. So now you can see the voltage went up just from switching the resistors, because we got a lot more resistance on the low side. Makes it easier to get a high voltage. The low voltage is down at the very bottom. We will zoom in a little bit. This goes dark after a little bit. So now I have to turn the lamp down. You see it's nowhere close to even halfway, but we got to go down further than halfway. So I make it dark. We finally drop down. So remember that middle range, it will stay, the output will stay high or low. And so the lamp is as dim as it can get. The middle range is somewhere between this light level and that light level, which I can't obtain at this point. So you can see we have a full jump high or low at the output when the input goes high or low. But they're opposite. That's the main thing. The output is inverted from the signal. High input, low output, and then a low input leads to a high output. And to end this, we're going to take a quick look at the schematic. So of course we have to power the integrated circuit. We're using a 74HC14. Positive supply goes to pin 14 up there, and then pin 7, the negative supply ground, goes down there. So sometimes it's shown on the schematic, sometimes it's not. Pin 1 is our input. You can see that white jumper going to the top pin there, which is going to our light dependent resistor voltage divider, where the light dependent resistor is on the high side. That is the little jumper I clipped the oscilloscope probe to. And fixed resistor going to the negative side. And then we got the 2 resistors here. I just clipped to that resistor. It's probably why it's bent like that. That's the 2 resistors protecting the LEDs. So I've talked about this polarity indicator, basically, circuit in a lot of other videos. So we're not going to go over that too much. And all these other ones are inputs. The inputs are above the outputs, same as that one. And it's best to not leave them floating. So I put them to the positive supply, since I have a bunch of yellow jumpers doing nothing. So in any case, hope you enjoy. That's also the Schmitt trigger symbol right there. Not all NOT gates, which are the triangle with the dot at the end, not all NOT gates are Schmitt trigger ones. So if it doesn't have that Schmitt trigger signal symbol in there, it's probably not a Schmitt trigger. But if it's a 7414, then it is a Schmitt trigger. the letters there may be different in the middle. That has different transistors inside, so it has different limitations and stuff. Make sure you read the data sheet. But in any case, if it's a 7414, it's a Hex Schmitt Trigger Inverter. So, hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.